All right, good afternoon, year eights. Welcome back. Today's lesson, we're looking at the energy efficiency of cars. So we want to become aware of how different types of car motors are more efficient than others. And in particular, we're going to be comparing the traditional ICE or internal combustion engine. These are guys that use petrol and diesel and that sort of fuel to electric vehicles. We're also going to get an understanding of which one is faster and why, or basically what does energy efficiency have to do with it. Now, if you have a look at Sector, I've uploaded a couple of videos with some nice fast-looking cars. Basically, they race electric cars versus petrol cars and figure out which one's better. Do keep in mind, I think the lower one with the two Mercedes is from 2014. So the host complains about the range of the electric car, but remember that batteries are much better now and lighter. So yeah, watch those videos and then come back to me, please. All right, so hopefully you've watched those videos and you've got style open, and one of the first things you can see is a diagram of a hybrid car. It's a hybrid car because it has both a petrol engine, you can see the fuel tank in the red, the combustion engine, and then it's got a radiator at the front, which is quite important to keep the engine cool enough so it doesn't overheat and break down. And then in the green, you've got the electric plug, you've got some batteries there that are rechargeable, a little controller, and you can see at the front it's got a little electric motor. We're going to compare what's going on inside these engines. We're going to have a look at the energy transformations, and we're going to talk about the energy that gets lost along the way, and then calculate which one's the most efficient. All right, let's start with a petrol engine. So obviously, petrol engine initially gets its energy from petrol. Petrol is chemical potential energy. The energy is stored in the bonds between the atoms, and that'll be the first step in our energy transformation. All right, so that petrol goes from the fuel tank up through this petrol line to the engine, and inside the engine, depending on what size car you have some cylinders that will basically let in a little spray of petrol, then ignite it, so that that energy gets turned into three types. You've got kinetic energy, which pushes the piston back down. You've got a little bit of heat and a little bit of sound energy as well. Okay, so there's three types of energy being produced in that energy transformation. The reason there's three different types is because inside the piston, and you can sort of see it drawn here, there's like a little explosion, and that's what pushes the piston back. Okay, and it moves back and forth, and that's what ends up turning the wheels. But because there's a little explosion in there, that's where you get the heat and the sound energy. Okay, so those pistons are moving back and forth and are attached to a rod that twists. And because it twists and spins, it actually turns the drive shaft, which in turn turns the wheel. So that's a kinetic energy going on to be kinetic energy. But as it does so, you also need to be aware that some of the energy is lost as friction. So we've got some heat energy lost to friction. And if you think of the tires on the road, you also have some sound energy happening, being lost, just created and lost there as well. So the only really useful energy from that transformation is the kinetic energy, the heat energy being released as friction, and the sound energy are wasted energy. And it's a very simplified version, but there's three major energy changes happening in a petrol car. Okay, let's look at the electric vehicle. So we recharge our batteries and we store the energy again as chemical potential energy. So again, that energy is stored in the bonds between atoms. Now, obviously, as it leaves the battery, it gets changed into electrical energy. So it gets changed to electrical energy to go through the wires. And you're probably aware, like with your phones, when you're using your phone a lot, it heats up because the electrical energy is getting changed. The chemical energy is getting changed to electrical energy, but that sometimes also releases a little heat. And then we get to the electric motor, which is very, very efficient. at turning that electrical energy into kinetic energy, but you'd expect a little bit of heat energy as well, a little bit of friction. And then finally, the drive shaft and wheels, much like the other car, we've got kinetic energy, a little bit of friction, creating heat, and of course you'll have sound energy of the tires running on the road. Again, in each step, I've highlighted the useful energy, the green color. The rest of it, assume it gets wasted. Okay, so let's represent those as Sankey diagrams, remembering that the arrows show the direction that the energy flows. All the energy at each transfer needs to be accounted for, and bigger arrows mean more energy. So this is the petrol engine on this side. I'll just zoom in. No, it won't let me zoom in. Okay, so this is the chemical potential energy available in petrol stored in the tank. As it burns in the cylinders, some of it, quite a small amount actually, is changed to kinetic energy. And a lot of it is lost as heat and sound. That's why car motors are quite loud, especially when you're revving them hard. Then the kinetic energy of the motor is used to spin the wheels. So we've got more kinetic energy there moving the car forward. But again, we're losing more heat as friction, heat, because you want the tyres to stick to the road, obviously, and again, the sound of the tyres on the road. There's a diagram that could possibly represent the electric engine. I have left out the step where it's electricity going towards the motor, but what I really want to show is that quite a lot of the energy available in the battery gets turned into kinetic energy, because electric engines don't use a controlled explosion to do that. So they're actually able to harness the energy much better and be much more efficient. Now, you saw in the videos that electric engines are very quiet, so that's why it's such a skinny thing. And you still have some friction, you still have some heat energy getting away. And again, this is the forward motion of the car, a little bit of sound between the tyres and the road, and of course the friction that you want between the tyres and the road so you don't go off the road. Okay, so armed with that knowledge, what I would like you to do is answer these questions, and don't forget your equation that you learned how to use last lesson. Remember, focus in on that useful energy, which in the case of cars is kinetic energy that pushes the car forward. So you got a little bit of done. I've kind of already done question 10 for you, but have a go at yourself, see how you go. And finally, you just have to compare the two, the electric and the the petrol engines. So that's it. That's all I want you to actually do today. But if you're interested, you can have a look at this optional extension. Okay, it'd be interesting to see who would attempt that and how you wrap your head around it. Other than that, that's it for today. I will go through the answers for these last few questions tomorrow when I actually see you face to face. And I'll see you then. Good luck.